Hello again. We are back with the same data set that we had last time, and we're going to show you a couple of steps for inspecting the data within RStudio. Now I close the RStudio session and I can start it again. I can relaunch it by double clicking on this R project symbol here. So although we didn't save this script that we had written, I still have here what I typed last time. So this was using the read CSV function to read in a CSV file. I used the backward arrow, which is just a combination of the less than symbol and dash next to each other, and I assigned this data so that I don't have to be typing this long name anymore. So if we press Control Enter, the data is read in, and again we might want to inspect first of all the first 5 rows. So we use the square brackets to navigate between rows and columns. So before the comma is the rows and after the comma is the columns, and we're only specifying give us the first 5 rows from 1 up to 5 and give us all the column. So again I press Control and Enter. And it's a little bit hard to see here because of the way the screen is. I'll just expand that, and you can see here that there are some strange columns coming in that we had before, and we have cultivar with a dot after it, soil with a dot. So there are some strange features here that I'm not quite happy with. Now we can try and correct it here with an OR, but probably the simplest thing is to go back to the Excel spreadsheet itself, in this case the CSV version, and let's have a look what's going on. So if you notice here, the column headers in this particular year were given an exclamation mark. And now it wasn't because the students at the time were so enthusiastic about cultivars and soils. It was actually because we used to use a different software at the time, GenStat. And GenStat needed these symbols to recognize these columns as experimental factors. Now as we're working in OR, we don't need to do that because OR will automatically identify these as factors because they're character strings, they're not numeric data. So we've deleted these exclamation marks from these first 3 columns. We'll save that, Control S, and then close the CSV again. Now I've made a change to the data file, the CSV Excel file. Now if I run this command again, so if I press Control and Enter, it'll overwrite the previous version of data. So you can always fix something and run it again in OR, and this time now the new version that we have should be corrected. So again, if we look at the top 5 rows of that, you'll see immediately that those dots have disappeared from after the name cultivars and so on, and as well as that the last 3 columns which were very unexpected, which came in for some reason, have now been removed from the data set. So we don't have to worry about that anymore. Now it's also important to find out how large your data set is, and we do that using the dim function. So this gives us the dimension of the data. So if we say dim of data, press Control and Enter, in the console below we see that there are 120 rows and 8 columns. You can also use the tail function if you want to see the bottom, so the head and the tail are another way to see the top and the bottom. So again, this will make sure that the last line is indeed correct. Okay, well the next thing to have a look at quickly is each of those columns. So for instance I use the dollar symbol to pull out the cultivar column, press Control and Enter, and here you see just the data from that column, so all the names of the different cultivars, and they're also specified below. Again, as this is an experimental factor, there are 5 different levels for this specific factor. We might want to look at the other column, so again the dollar symbol, drop down menu appears and we'll select the soil column, and here we'll see that there are 3 different soil types: medium, poor and rich. Now the order of these is not necessarily logical, it's alphabetical, and we may want later to reorder these, but we're not going to do that right now. We're just having a quick inspection on the data to see that everything is as it should be. In the 3rd column there's the last of the experimental factors, which is the replication. That's the student group that was involved. And again, if we press Control Enter here, you'll get the different student groups. They were given different colors, but if you notice now at the levels that are specified, you'll find that this is a slightly longer list than we should have. So for instance, the purple group inputted their data with 2 specifications, one with a capital P and one with a small p. And this is a problem because R will interpret these as two separate levels of this, so two different replicates, whereas in fact they're actually one and the same. And the same can be said for the red groups and the white groups. Now it's possible to correct for this within R, but again the simplest thing to do here, I think, is just to go back to the spreadsheet, original spreadsheet, and correct it ourselves. So let's have a quick look at those columns for replication. So if we go, for instance, for red, we can see that all of them have a small r except for the first entry. So we can just correct that by hand. And similarly for the other two involved. So we had a purple with a capital P. We can make that into a small p. And I think for white as well, we have also the first entry was with a capital letter. Oops. There we go. Now again, save this. And we can quit it. And we go back through the same process as before. So again, we overwrite the version of data that we had now with a new version. And now, for instance, we'll see what's happening with replication. We now see that the capital P purple has disappeared and the capital R for red has also disappeared. So we're now with a more correct version of the data as we want it. One final thing is to have a quick look for outliers, potential outliers, and a good way to do that is to plot, so to visualize them. And so, for instance, we may want to look at the difference or the relationship between the biomass of plants that are inoculated versus ones that are not inoculated. So we use the plot function, and the plot function takes as its first argument the x variables. So if I select this and press Control Enter, I can see these are just values of the biomass of inoculated plants. But I can also add as a y variable the biomass of not inoculated plants, and then if I just plot those against each other, you can see over here in the far corner a plot is produced showing indeed that there's a clear relationship between inoculated and non-inoculated values of the same cultivars over the different replicates. But there are no outlying values that we can see here that we have to be suspicious of. If you don't have if you just want to look at one particular column on its own, for instance, we might want to look at the levels of infection. We can use, for instance, a scatter plot. Again, that's just using the plot function, a basic scatter plot. And here you see, well, there's one slightly higher score here, but in general, the data all fits together quite nicely. And I think the last columns that we're not particularly interested, and they are to do with the number of plants for these inoculated and non-inoculated. So that's a quick way to get a look at your data and to make sure everything is correct. And that's what we recommend to do at the start of each analysis. Have a first look at the data and make sure that there's nothing strange with it.